Hello, so welcome everyone to SUMO Speaker Series number 4. This week we have Ashley Brinson to speak about some new exciting projects he's working on. And I'll let you take it away, Ashley.
Thank you, Josh. Look, Josh asked me to introduce myself first, and then I've got some slides and pictures I'll talk to you about. My background is originally in chemical engineering. I took an MBA about midway through my career. And when I came to Sydney, I studied at University of Sydney Law School to learn contracting, corporate law, and intellectual property law. So I am an engineer and a lawyer. Right now, I'm director of a couple companies that I own. The company is called Brinson Associates. B&A sponsors SUMO. We've kicked some money your way a couple times last couple years. B&A spun out a company called Greener Technologies in December, and it is its own company now, Greener Technologies Propriety Limited. And then I'm director on the board of a company called PT Blink, a construction technology company. So I've got a few different things going, but the opportunity I wanted to talk to you about today is what we call solar robotics. It is the idea that you can use industrial style robots or single construction task robots to accelerate the green energy, zero carbon emission energy system that we need in the future. So I'll talk to you about that. This is really informal, and I'm going to speak from a pitch deck that I haven't used in quite a while. And the reason for reaching out to SUMO at this particular time is the design that you'll be looking at was invented by Evan Mack, Kit Ney, and George Khalil. They're three recently graduated or soon to graduate for Kit's case, SUMO mechatronics engineers from University of Sydney. And I'm looking for some engineers that can take their design and build the end effector of the robot that they got the design to a certain stage last year. And that project has been funded by the New South Wales government. And we've got funding to build the end effector and to hire some students to do that, or to hire some engineers to do that. I do have a lot of belief in the rising generation of technologists and the alignment of principles and the ethos of younger technologists in solving the problems of the world. And the clean energy problem or clean energy opportunity, depending on how you look at it, is one of the biggest problems in the world. So I'm going to share my desktop, which is a bit of a mess, and I'm going to maximize this out and talk about solar robotics. Can you see that, Josh?
Yeah. Are you making it up full screen?
Is it full screen or is it?
Yeah. No, I think it's
okay. Okay, cool.
Now.
Terrific. There may be a little lag there. And look, if you've got a question, throw it into the chat. I see there's only one chat, and that's Josh inviting people to throw a question into the chat. If I see a number tick up there, I'll stop and read off the question. Look, the image there is a cartoon that we had drawn up that would imagine what it would look like if we went to a solar construction site and teched it up. And right now, Australia is set to be the home of the largest solar farm on the planet. That'll be a project that's built by Sun Cable in Elliott, Northern Territory. They're planning on, I believe they've announced 15 gigawatts or perhaps even larger for a solar farm in the middle of the outback in Northern Territory, with a cable that would stretch to the Java Sea to Singapore and to Jakarta, and light up Singapore with 10% of the power going to Singapore coming from an Australian solar farm. So that's a bold project. It would be intercontinental transfer of solar energy from Australia to multiple countries on the end of the wire. It's very much the kind of project that was the Trans-Pacific internet fiber optic cable that went from Seattle to Hawaii and from Hawaii to Sydney, and from New Zealand up to Hawaii, and from Hawaii to Los Angeles, in sort of a figure-8 redundancy circle, so that the internet that we get is a combination of that fiber optic cable plus satellite internet now. I believe a similar kind of radical transformation is underway with clean energy, and because of the very high solar insolation in Australia, I believe this is a great place to put some new field robotic solutions out and help support construction. I'll show you what construction looks like. This is a bit of a cartoon, but this is sort of, if you took everything techie and put it together in one place, how might you construct a solar farm? And we're calling that solar robotics. The problem that is out there now is that the method for constructing solar farms can't scale up. The projects that have been built in Australia up until now were in the range of 10 megawatts, 100 megawatts is pretty large in the past. But the farms that are being built out in Orange and especially in New England presently, the Oxley solar farm will be 200 megawatts. The New England solar farm will be 400 megawatts. And Sun Cable has announced 15 or maybe 20 gigawatts. There are a number of 5 gigawatts plants that are spoken about in Western Australia. And these projects are huge. They're enormous. They would be tens of millions or hundreds of millions of solar panels that would have to be installed in the outback, in places that are chosen because of very high solar insolation, which means they're very hot in the summer, and because the land is cheap, they're very far and very remote from cities and towns. So this kind of construction would be akin to constructing a solar farm on the moon. In fact, I'm sure that there will be companies and new technology ventures aimed at delivering renewable energy on the moon, not because renewable energy is needed on the moon, but because it's the only way to get electricity that would be necessary for building the station there that would go on to Mars in the future. But the projects that will be here in Australia are 1,000 times larger than what we've seen in the past. That's what's coming. And that's the opportunity and the problem. This is what a solar farm looks like if you haven't seen one up close. The rows and rows and rows are very repeating. These are the solar panels. Generally, these are maybe 30 meters long. And the white things that you see there are transformers taking it from direct current to alternating current and then putting that onto the grid. And this isn't a huge one, but it's a pretty good size one. The technology, these are fixed, so they're always pointing in a certain way to the sun, but the prevailing technology today is a single axis tracker, so that there's sort of a pole that is on a motor that will rotate east to west. In the morning, the solar module turns to the east and catches the morning sun. At midday, it lays flat and catches the sun directly overhead. And in the evening, it turns west and catches the western sun. In the southern hemisphere, the sun is mainly coming from the north, right? Yeah, from the north. And so if your solar field is near the equator, you can lay these pretty flat. If your solar field or if your solar panels are on the South Pole, you may need a 2-axis tracker to get the maximum amount of energy. But where we are in Sydney and New South Wales, a single axis tracker is the preferred technology. Look, there are a couple of quotes there. I think I put this deck together in early September. And these were coming from global leaders in renewable energy. The first quote there from Chris Ashton, CEO of Worley in the US, was that the volume, the sheer scale, the volume of energy infrastructure that has to be built and the speed at which it has to be built, this hasn't been done before in human history. It is very much like it's just a huge undertaking for the amount of energy infrastructure that has to be built. And then that second quote there from the UN Secretary General about how dangerous it is that we are getting to the end of the time for taking action on carbon in the atmosphere and on climate change that we're all seeing the effects of, whether it's flooding or bushfires. We're either too hot or too wet in New South Wales, and you all know what that looks like. So this is what it looks like when a solar farm is being constructed today. I'm not sure that this is an Australian example, but this is a typical example globally. It takes 3 or 4 people. They will get a pack of solar panels that's on the ground like this. They're shipped in the horizontal so that the glass doesn't break. And one by one, they're lifted and bolted into place on a rack. This is tens of millions of solar panels are being installed this way right now in conditions way far out in the outback where it's just there aren't many people and there's very little facilities for housing people or for caring for them. And the situations are quite hot. Lifting solar panels all day long, it's sort of like a day at the gym, but when you have to do that for 8 hours, the workers are at risk of either heat stress injuries or repetitive strain injuries from doing exactly the same task over and over and over. And for those of you who have studied robotics, you know that jobs that are dangerous, dull, and dirty, those are the jobs that you want to give to a robot. And so this in my mind, this application is ideal for robotics. The team undertook a design brief last year, about 9 months ago, I'd say, and we were showing it to some clients or some potential clients. And this is one of the variants of the minimum viable product and what we thought we would do. This is a 6-axis robot mounted on the back of a vehicle. In the long run, it wouldn't be a truck like this. It would be a rubber tracked undercarriage vehicle, but the solar panels would be on the back like they were with the manual laborers, and one by one, the robot end effector, a vacuum cup end effector, would grab the solar module, pick it up, put it in place, and then at least in the early years, we would have that, or even in the early deployments, we would have human workers here grabbing the solar panels, holding them in place while they get bolted in. But the brunt of the lift, twist, place, lift, twist, place, lift, twist, place, that task would be undertaken by the large 6-axis robot arm. So that was the plan. That was the basic design that the team came up with. We took that to some clients and they were pretty happy with that. You can see some of the quotes there. And so we got letters of support from these 3 guys, one from New England Solar Farm, one from Oxley, and one from Demeric. Stapled that all together, sent that off to New South Wales government, and we got funding for building the end effector. We think that the total robot will cost about $1 million. It'll cost $500,000 or $1 million to run it for 6 months or a year. And we've got some estimates there. Overall, I think this is an attractive opportunity, a robot as a service, and the ramp-up rate for solar installation in Australia is enormous. So I'm betting a certain amount of my time on this company and on this opportunity. That's the team that we had a year ago. I'm still working closely with India and Daniel and Jack. Tennille is available for some marketing, but unfortunately our man Kit and our man Evan and our man George Khalil have graduated and gone on, and they're doing some full-time jobs now. So I'm looking for a sprint team that can take this design for 6 or 8 weeks in the term break and build that robot end effector that the robots would use to lift solar panels. That's me. I'm Ashley Brinson. That's Greener Technologies, the company that we're working with, and that's the Solar Robotics Solution. And I would be really pleased. I know that that's a quick run through, but I'm really pleased just to have a discussion with you about solar energy, about robotics, about your careers, about startup companies and entrepreneurship. And if that's something you're interested in, drop me an email at ashley@brinson.com.au. You can find me. I'm easy to find on LinkedIn or wherever, and you can jump in on me on LinkedIn too. But that's solar robotics.
Wow, thank you, Ashley. That's seems like an amazing product. I'm chucking your email now in chat for anyone who wants to get in contact, and I'll drop it in the Facebook event also. So I'd like to open the floor to any questions. As Ashley said, he's happy to chat about any of that stuff. He's very knowledgeable in the field, so I'm sure he'd give you great answers. So fire away, guys, if you have anything, wondering anything about the world of engineering, about solar robotics in general, go for it. If no one is starting, I'll start. You talked about how the one axis panels are a lot more efficient. So what would the installation process, the difference in the installation process be between the flat panels like they do now and the one axis panels?
Look, the fixed mount solar modules are the standard until now, I would say. In Sydney and around New South Wales, we see a lot of rooftop mounted solar panels. So depending on where you live, if you live in a suburb, you may have these on the roof of your house. That's a form of fixed mount solar modules. Generally, the angle of the mount is the angle on the roof. You can angle them a little bit differently, but generally it's the angle of the roof. There's a general rule of thumb that if you're going to mount something fixed mount, the angle would be approximately whatever your latitude is. So I think we're at 27 degrees latitude, and it would be 27 to 37, something like that, degrees for a fixed mount. But if you can turn that, and that would be facing to the north, because the sun is coming in from the north. I think. Yeah, the sun's coming in on the north, and it's opposite in the northern hemisphere. And sometimes it gets mixed up in my mind because you can tell from my accent that sometimes my brain is in the northern hemisphere and sometimes it's in the southern hemisphere. But if you can, instead of mounting it always pointing towards the north, if you put it on a north-south axis and then tip it to the east, you can catch that sun. So the tracker costs money. The cost of the tracker is not insignificant, but the uplift in power and the efficiency of dollars electricity per dollar capital investment, and what we call the levelized cost of electricity, it's favorable. And so tracker companies, the most common tracker company is Next Tracker, NEX Tracker, Next Tracker. ATI, Array Technologies Incorporated, is another major tracker, and some of the solar module companies are also looking at single axis trackers. The two axis trackers are mainly research or Nordic Europe or North Pole, South Pole applications, and they pivot around on a gimbal, and they can go in any direction and track the sun. So there's not a huge amount of movement of the sun between the summer and the winter, but we do definitely notice it in Sydney. You know that the days are shorter, whereas on the equator, you get 12 hours of sun, 12 hours of dark, and the sun's generally in the same position every day. And the further south you go, so if we were to go to Victoria or South Australia, or certainly in Tasmania, depending on things, it would be a bigger difference between the summer and the winter, and more of a justification for increasing how much you can pivot the solar modules around. Did I answer your question? Was your question just about the cost of engineering?
It was that, and also in relation to the solar robot, the actual robot.
Right.
How do you think? To what degree do you think the complexity would increase? Because I know the whole reason is about scalability of the installation process. So, do you think the robot would be a good fix to that complexity problem with the axes compared to the fixed ones?
I don't think that's going to matter a huge amount. The drop-off position is going to be at a certain angle. It's going to be a straight line across because the solar modules go on a straight line.
Yes.
And the angle will be a fixed angle. You wouldn't drop it off vertical like that. You might drop it off flat, but actually, because somebody needs to get behind it and screw in bolts to hold it in place, and that may be manual. The bolting may be manual, at least in the first instance. Probably you're going to be laying them on a few degrees, 45 degrees or something like that. Laying them vertically, if you had someone lying on their back with a screwdriver, that might be a great way to do it, because you could hold it there with the robot. And if you had a little robot like a Boston Dynamics spot underneath doing the bolting, that would be fine.
Or like some kind of spot welding underneath along the track. I think
generally it's not welded, right?
Yeah.
I see the question there from Maximus about perovskite solar cells. So the solar cells there are two types of solar cells that are most common today. The market dominating solar cell is a silicon solar cell. 5 years ago, it would have been cheap to have a multi-crystalline silicon solar cell. Today, the companies that are bringing solar panels up the economy of scale curve very rapidly are especially located in China, and they are very good at manufacturing single crystal solar ingots and then sawing out single crystal solar wafers. So that's the solar cell of preference today. There's some minor solar cells, cadmium tellurium solar cells that are cadmium's toxic, it's not great, and copper indium gallium selenide CIGS solar cells. Those have rare metals that make them a little more difficult, or even difficult to get the materials to make. But there is a rising new solar cell type called a perovskite. Perovskite is a mineral. You can make solar cells out of perovskite all on their own, or you can add a layer of perovskite onto a multi-layer solar cell and get some additional sunlight. Some of the wavelengths will respond to perovskite that aren't converted. The photons in those wavelengths aren't converted by silicon, and so perovskite is a rising solar cell technology. And I believe also that you can focus with a mirror lots and lots of sun on a perovskite cell, and you can have a really small cell with lots of solar energy focused on it, and that makes it a bit cheaper.
Interesting.
So yes, I do see them taking over the industry, especially in niche applications like space. I believe Professor Anita Ho Bailey at University of Sydney has come over from UNSW, and perovskite is her thing, and it's a real goer.
Sounds interesting. Anyone have any other questions? Feel free to ask now.
What does my team do on a daily basis? Right now, I've got 4 teams that I'm working with. Brinson Associates is running 2 consulting projects. One consulting project is called the Zero Emission Copper Mine of the Future project. We're looking at a copper mine, let's say that it's in Australia, and how to move materials around the copper mine with 0 carbon emissions. So that means the trucks that are dump trucks need to be converted to a different drive besides diesel, because diesel, when we burn it, we get carbon from it, obviously. And so the big monster trucks that run out on the outback need to be converted to monster lithium ion battery trucks, or they need to have an overhead trolley system, the tram in Melbourne or something similar, where overhead wires power the trucks and bring them up out of the mine onto the road, or maybe they are hydrogen fuel cell vehicle trucks. But basically, to create the solar panels and the wind turbines that we need for zero energy future, we're going to need a lot of copper and a lot of copper wires. And so we're working on zero emission copper mine of the future. Tuesday's Copper Day. I meet with the copper team on Tuesday. I've got a partner with another consulting team. I've got one PhD student and 1 honors student from UNSW that works on the Zero Emission Copper Mine of the Future project. We meet with a group of industry people 5 o'clock to 6 o'clock on Tuesdays, and we give them an update on the project that we're running. And then the rest of the day, we're researching technologies for materials movement that are 0 carbon materials movement things. On Wednesday, it is a project where we're consulting with Sun Cable to talk about how Australia might make its own solar materials. And that project is, I've got several UCID chemical engineering students working on that project, and 1 chemical engineering professor who's doing some work on the side, and then 1 UNSW solar cell researcher that works part-time on that project. That's all around domestic manufacturing of materials. And then Greener Technologies is waiting for some new engineers, and some of you will pick up my email and email me, and we'll get a couple or 3 mechatronics engineers to take that project forward. The other 2 or 3 days a week, I work with PT Blink, and we are building technology that will build, say it is a 10-story to 45-story apartment building. 3D design, like a SolidWorks design. You're probably studying SolidWorks. You can design all the components in the building, have a robot cut the steel remote from a construction site. So all the floor plates are stacked up on each other on the back of a truck. They come to the construction site, and very rapidly you can build you can make a property development in an urban setting very, very rapidly, with everything designed away from site and cut with robots. And then when the construction happens at site, the dimensional control is very tight, like 5 millimeters tight. And then other things like a bathroom pod, conventionally you'd have maybe 10 or 15 different trades coming into a very small space to do their work. So an electrician, a plumber, a tiler, a waterproofer, a painter, someone installing cabinetry. And so they have to come, one trade comes on Monday, a different trade comes on Tuesday, a different trade comes on Wednesday, and so forth. Instead, all of that can be done in a factory, and the bathroom pod can be nearly finished remote from the construction site. And you can have bathroom pod day. A truck comes with 20 or 200 or 2,000 bathroom pods for a hospital, for a hotel, for student accommodation, or for an apartment. And the building has been designed so that the floor trays and so forth allows pick bathroom rods in and drop them in. Super fast construction, sort of like Lego blocks. The same for facades, mechanical, electrical, plumbing modules, but modularized construction and offsite manufacturing, QA, and deliver that to construction site. We're working on that at PT Blink, but we're also working on a lot of digital tools for APIs, apps that do solve computations and connect lots of things together. I came to the industry night over at Science Road. I forget what the name of the building is there, with Will Watts, an American engineer, and we met some of the students it was about a month or 2 months ago. That's PT Blink. What I do on a daily basis, I read a lot of contracts. I do a lot of business development and work with the team with the different teams. What about software? Yes, I do. We need lots of software engineers. Robots are great and robots are fun, but software drives it all. And with PT Blink and with greener technologies and solar robotics, we need software. So yes to software. Software is everything these days. Software is the part that is the most scalable, and whether it's robot control, whether it's sensors, machine learning, artificial intelligence, logic solvers, yes, it's all software.
Very cool. I always thought the construction industry was outdated anyway.
It is a bit outdated. Many of the techniques are the same as they were 50 years ago, and yet everywhere else around us, we've seen remarkable leaps forward in productivity and automation. So construction is the last holdout. Construction is the last holdout, and Australia is a good place. Japan is a good place because there's a lack of young people being born coming into the construction industry as sort of 20-year-old, 25-year-old construction laborers. But all of America is not the same. California has very high wages. Germany and parts of Europe have high wages. Australia has high wages. And so what that does is it means that if you can, if I can have a team with one construction laborer and 2 engineers, I might get higher productivity than a team with 5 construction laborers. And I might be able to get a situation where the output is more predictable and the business case is more controllable. But that's not to say that robots should replace human labor, but increasingly, if you look at an automotive assembly plant, whether it's Elon Musk or even just Ford Motor Company in Detroit, robotics are overtaking because of the fine reproducibility and the quality of the control. Robots are dominating. So there you go. What are the leading countries in the world for solar farm installations? Australia is on the top 5 list. California, the United States is disparate. So there are states where the sun doesn't shine, like Alaska or the states on the Canadian border, but California, Arizona, New Mexico, Nevada, the southwestern United States has high solar insolation, and the land is not as useful for farming or for other large land demand uses. In Europe, it's southern Europe, so Spain. Let's say Spain is one of the big countries. In Africa, it's North Africa and the Sahara Desert locations. In Asia, it's India. There's some places in China that are good, but Australia is the 3rd, 4th, 5th largest land mass. And because of so much outback land, And because of such high solar, it's called insolation, INSOLATION. Australia is one of the best places in the world. And with only 25 million people, the potential to convert that solar energy to hydrogen and to ship it overseas, or to use solar energy for domestic manufacturing makes Australia a great place to install solar.
That sounds awesome. For all the viewers, I've just chucked the attendance form in the chat, so make sure to fill it out. So make sure you get your PEP hours. But yeah. So actually, I have one more question. Have you ever thought about other forms of solar energy away from like solar panels? Like I know there's those other kinds of farms that I've seen before with the like sun towers in the
Right.
middle, mirrors placed around. And I think I don't know exactly how they work, but I think it's got something to do with heating water and
Right.
kind of steam engine.
So look, I'll pull up a website, which is an Australian company, and you can have a look at these guys. Brian Menzies is in their company. They're called Vast Solar. They are a concentrated solar power company. I'm gonna pop them in the chat here. The type of solar that you're describing is generally called concentrated solar thermal or concentrated solar power. There's a heat transfer fluid. There's a fluid somewhere there. It could be in a tower. I've got a picture of a tower. I'll pull that. It could be in a tower. And the heat transfer fluid could be pumped around, but the most common material is molten salt. So sodium chloride, table salt at about 800 degrees centigrade. It gets pumped around. It goes to a steam heat exchanger, water heat exchanger, where the water is pressurized and gets really, really hot. You drop the pressure on the water, it turns the steam turbine, and the turbine creates electricity. The nice thing about concentrated solar thermal is that when the sun is down, you could have a big tank of hot molten salt that could keep the power going until midnight, 2 o'clock in the morning, 3 o'clock in the morning. And then you could have solar modules, solar PV that's running through the day. Your solar thermal could run into the night, and then you could have a lithium battery or hydrogen, a water electrolyzer, and hydrogen storage and fuel cell on site that's running from, say, 2 o'clock in the morning until the sun comes back up. So these hybrid systems are really common now. Bass Solar just built a hybrid system, or they're in the process of building one up in Queensland, affiliated with one of the mining sites. And with that, you can also bolt onto that a diesel generator, so that if you have really bad weather for a really long period of time, you've still got a means of making power. Instead of using mineral oil diesel, you can use biodiesel, which is coming from old chip fat fryers, or any kind of algae biodiesel. You could use ethanol, which is a renewable energy. In Europe, it's common to have a biogas, which would either be pyrolyzed wood chips or straw. You heat it up, you char it, you get some hydrogen and methane off that. You burn that as your energy, and you literally have a silo of. You could use charcoal also as a renewable biomass energy source. But if the sun's not shining, you can use backup fuel that's not fossil fuel. It's sort of a biofuel. So yeah, concentrated solar thermal. The Vast Solar guys, if those of you who love chemistry and remember the high school chemistry experiment where the teacher broke off a chunk of sodium and threw it into the water, and it caught fire or fizzed around, they're using molten sodium in a loop. Which seems a bit crazy to me, but they've got a system designed around molten sodium. molten salt is common. I don't think there are organic heat transfer fluids that do that, but and there's a difference. One style has got parabolic dishes and a tube that goes to the parabolic dish, and the sunlight is on a pipe or on a tube through the parabolic circle. And then the other type is where lots and lots of mirrors point one tower that's glowing at 1,000 degrees, 2,000 degrees. Those are the ones that are smoking the birds when they fly past. But both of those are CST, concentrated solar thermal. Cool videos, cool pictures online. A lot of those applications in Spain. We just for the zero emission copper mine of the future, we looked at 4 of those that were built in Chile in the last 5 years or so. And the state of the art and the best technology in South America at the moment is the PV is cheaper than the concentrated solar thermal. But if you've got a process that requires thermal heat for industry, the CSP is useful. And of course, after the sun goes down, you've still got heat.
Awesome. Okay. If no one has more questions, I had one more thing that I'm sure people are curious about. For the engineering role you're offering, what would the expected so not necessarily experience required be, because it's a student role, but maybe background knowledge
Look,
point in career?
Later years mechatronics engineers are preferred over earlier years mechatronics engineers. We're going to be building something. This is not study work. This is I need to build a bench. Step 1, build a bench. Step 2, go buy some tools. Step 3, go buy the robot end effector and put it all together. Step 4 will be hooking it up to an air supply and or vacuum system and actually lifting one solar module 100 times and see if we break the solar module, but testing it out. So hands-on, not study work. And if you've had experience with solar card team or anything like that at the university, that would be very helpful. If you've had SolidWorks for design modeling, that would be helpful. I will listen to all comers and look at all CVs that come in and put together a team that would have a good shot at building a successful end effector. And this sprint will only be the end effector. When we get the end effector, I'll be looking for an academic or a community robot arm to mount it on, and that may be dictating what the end attachment is on the robot arm. But yeah, if you're interested, if this sounds interesting, I pay good wages, and it's fun work. I'll also be paying. We also have the option of paying out some shares in a new company and ramping up the company a bit. So I do enjoy working with students, and I know you've got time available in the semester break. If this sounds appealing to you, drop me an email after we get off, or look me up on LinkedIn and let's talk.
Sounds like an awesome opportunity. I would recommend everyone to apply. I think if no one has any more questions, I think we'll be good to wrap it up today. Just one more note, everyone, make sure you filled out that form. I'll quickly chuck Ashley's email in the chat one more time for anyone who also missed out that before, so they can reach you, Ashley.
Thank you, Josh.
And yeah, if there are no more questions, I think here's the email one more time. I think we'll see everyone next week. Thanks for coming. Everyone, make sure to thank Ashley for that great talk. I, for one, found it very interesting. I think it's an amazing way of upscaling the solar industry, which is a necessary point we need to get through. in our race to renewable energies.
Good luck with your end of semester assessments, exams, and all of that. And we'll see you down the road. Thank you, Josh.
All good. Thanks, Ashley.
Bye-bye.
Thanks for coming, everyone. We'll see you next time. Bye-bye.
Bye-bye.